Okay, what we're going to do now is just briefly revise flood hydrographs, all right, and then why we use them. So you can see a typical flood hydrograph here. Obviously, this one here is indicative of something that has a very short lag time. So remember when we're looking at these, we're looking at lag time here, right, the difference between peak rainfall and peak discharge. We're looking at the rising limb. Remember when we look at our discharge here, it doesn't start from zero, right? Because that would mean that there was no water flowing in our river channel here. Okay, so we're looking at the rising limb here, whether or not it is steep or gentle. That's the first thing we should really look at. And then when we look at that, we look at whether or not we have a high peak discharge or a low peak discharge, right? So we're interested in the rising limb. Okay, so it shows the river responding to a rainfall event, right? So if I've got a steep rising limb, then that means it could be from heavy rainfall, I might have surface runoff, and then later I might have through flow. This will be determined by a number of factors, right? Deforestation, that could reduce interception. It might mean that we have the soil, depending on what type of soil it is, filling up a lot quicker, so more surface runoff and a shorter lag time. Urbanisation, obviously that means that we have an impermeable surface, right? So we've got more gutters, we've got more channels, rooftops have gutters, right? So everything to get water out. So our surface is predominantly impermeable. So our main process would be overland flow or surface runoff there. We might have soil that is impermeable, so very clay type compact soils. So I might look at the geology, right? So the rock type, the surface type, and the precipitation, both type and intensity as well, all right? And also the antecedent moisture, so how much moisture is already in the soil if there is soil as well. There are other things that I could take into account. That could be relief. If it is a very steep gradient, then obviously there won't be time for infiltration, so I might have a very short lag time here as well, all right? So if you're asked to sketch one of these, remember, don't start at zero because you're showing me that there would be no water in the river channel. Base flow here shows the normal flow of the river for this time of the year. So if I have seasons, then base flow varies. Right, now this is something that is completely different. I can see here I've got a flood hydrograph with a long lag time and a low peak discharge, right? So I'm going to have predominantly a lot of through flow. That would be my main process, right? Now I could have lots of vegetation if I'm having a long lag time. My surface soil might be made up of porous or sandy type soil, which allows a lot of infiltration. It might be very, very flat, so a floodplain area, which also allows a lot of infiltration as well here, okay? Things I can do to manage my lag time. Obviously I want my lag time to be a lot longer. That means I'll have lower peak discharge and more through flow, being the dominant process as opposed to surface runoff. I could terrace slopes, right? You can see these terraces here that would give time for infiltration to occur. I could plant trees. Obviously that will increase interception and infiltration and delay and reduce surface runoff, right? Now the reason that we do this is we're looking at the probability of something occurring on a regular interval. Now if I look at a flood that is something that's 350 cumex here, right? I look at the return periods. It's quite high. So a 350-year flood, I might have every 100 years. So I get a lot of really important information from flood hydrographs. So each time there's an event, it can be recorded in terms of its magnitude. You can see that there's a positive correlation here, right? So magnitude means the size. So I'm saying here something with a peak discharge or a discharge of 350 cumex is very, very high. So this information is really vital for planning, all right? So I can see a positive relationship. When discharge is high, so 350 cumex, then the return period is also high. So I hardly ever have that, right? When discharge is low, then I'm going to see that I get this maybe quite regularly. So it might be every year, every month, right? This is really important because with this information, I can plan, I can forecast, I can predict. So this is vital if you get this in an examination question. So again, flood hydrographs with all the information that we can plan, prepare, predict, and forecast. All right, so things like management strategies, land use, zoning, etc. So this is the reason we look at these.